Hello there. Today I'm going to be graphing the number of COVID-19 cases over the last couple months, talking about linearization, creating an equation, and then I'm going to be predicting the future. But first, let's find some coronavirus data we can graph. On the website ourworldanddata.org, I found a graph with the number of COVID-19 cases on any given date. We can then graph the data with the number of months since January 1st, 2020 on the x-axis, and the number of confirmed COVID-19 cases on the y-axis. This produces an exponential shaped graph. But before we find the exponential equation for that graph, let's talk about linearizing and the least squares regression line. Our data follows the general equation of y equals ab to the power of x. So to linearize our data, we need to take the log of both sides. By doing so, we can set log y equal to log ab to the power of x, and we can distribute the log, and through exponential rules, we get log a plus x log b. In general, this follows a log y equals mx plus b equation, so we can carry on. When we graph our log y against our original x, we get a linear shaped data set. Now we need to find the LSRL, or the least squares regression line, which is a line that creates the least amount of distance between itself and each point. In essence, it's a line of best fit. To find the equation of this line, we go to our calculator and enter the x and the log y into a list, and then find the linreg ax plus b function. By running the function and selecting our to list, we get an equation for a line. Using our data, we get the equation y equals 1.259x plus 2.03. This function also gives us an r value, which is a correlation coefficient. We want this number to be as close to 1 as possible, so our value of 0.941 is pretty good. Now we must convert our linear equation back to an exponential. First, we must remember that our equation is in the form log y equals mx plus b. First, we must raise 10 to the power of both sides. This creates the equation y equals 10 to the power of 1.259x plus 2.03. which we can rewrite as 10 to the power of 2.03 times 10 to the power of 1.259 to the power of x. We can simplify this equation to y equals 107.2 times 18.16 to the power of x. Now we can put this exponential equation over our original data, and we see that it matches pretty closely. Now, let's attempt to predict the future. I want to know how many COVID-19 cases there will be on November 1st in 2020. That's about 10 months since January 1st. So we plug in 10, solve, and the equation says that we'll have 416 trillion cases on November 1st. Our math was all correct, but we forgot one little thing. There has to be a maximum population. We can't possibly have 416 trillion cases. In the future, our graph is going to start curving back down and flattening out as it approaches the max population. We have to assume that every single case will reliably infect other cases as well. Our equation cannot predict the spread based on people who travel more than others, or those who wear a mask or not. And thus concludes our story. I guess I couldn't really predict the future in a little 4-minute video. Oh well. I hope you all learned something. Stay safe, stay home, and thank you for watching.